What's up, grade 11s? Welcome to your Life Sciences show. I am Looney, and with me is Aslam again.
Hi, welcome, grade 11s. You must say welcome to me. I am stepping into your territory.
Yeah, why are you here for 3 hours? I don't know. Anyway, my sisters, Aslam, what are we doing for the grade 11s today?
We're looking at human nutrition, continuing from Llewellyn's topic last week of nutrition, but we're focusing more on the homeostatic control of nutrition and a little extension of the end of nutrition of last week.
All right, my sisters, we also have Raven in studio with us, but I won't go to him because I'm hoping that you guys are watching for the grade 10 show because I need to tell you a whole lot of stuff. So make sure you hit us up on facebook.com/learnextra, and then you can hit us up on Twitter as well at learnextra. You can download the show notes, the videos, and the schedules on learn.mindset.co.za. And then if you want to win yourself this awesome Casio calculator, all you need to do is complete the test yourself entry on our Facebook page. I'll post all the information that you need to know, and then you'll have yourself this baby if you get all your answers right and you're a bright child like Raven. Okay, so remember, guys, test yourself and everything else. And if you don't get through your questions right at the end of the show, remember when you ask all your questions right at the end of the show, if we don't get through them, remember you can send them through our help desk. And the Learn Extra Life Sciences help desk is proudly brought to you by Axel. So please make use of it, guys. The address is learn.mindset.co.za/help desk.
It's getting faster all the time, Raven. You
No,
notice?
I
notice?
felt like I was so slow. No,
Eh?
please don't judge me. Thanks.
She's getting faster. It's
No.
good. It's a compliment. It's not a criticism, by the way.
Oh, okay.
You're giving us more time, and we love more time.
Oh, no, that's fine.
Okay. So what are we looking at, guys? We're looking at egestion. Not a nice thing to look at, but nonetheless, we're looking at, or we're discussing egestion. We're not looking at egestion. Please don't watch somebody egesting. It's not a nice thing to do. Examine, define, and understand homeostasis. So in other words, what is homeostasis? And how does it play out in nutrition? Which part of nutrition lends itself to this homeostasis that we're talking about? Define good human nutrition. And guys, this is put in a syllabus because we as human beings, Raven, Aslam, Looney, and so many others, we do not have good eating habits. I talk for myself. I shouldn't be saying for the other two because I'm not sure what they eat. Healthy, unhealthy?
Bit
Okay.
of both.
A bit of both, Raven?
Yeah.
I eat
From
well.
judging from your physique,
Yes, yeah, no,
physique,
healthy. Yeah, healthy.
He's like me,
Yes.
healthy, eh?
But it could be like Abram. You know, Abram, he's like this, but he eats like this.
Hey, Abraham, you're hearing what they're saying about you.
Yeah.
Okay, so we're looking at a balanced diet. This is the reason why this was put in a syllabus, to not to teach and to examine so much, but to make us aware of good eating habits and how we can promote it in our families and ourselves for a start. Very important to eat well, people. Define malnutrition. We'll talk about that later. Look at and describe types of malnutrition. So first of all, define what malnutrition is, and then look at some types of malnutrition. That's the show for today. And the challenge question, a long question, and it's in the form of a mini essay. As you can see, 20 marks. Again, let's see what our homework is going to be when we're answering a mini essay. First of all, we need to underline keywords. And for me, the most important keyword is the verb or verbs in the question. Okay? And in this particular question, I'm going to use green for that. Describe, one. Also describe. That's it. So, the two verbs we're finding are describe. And whatever comes after the verb is what you need to answer. And let's look at those keywords now. What? The homeostatic control of glucose. That's one. And also describe what? The causes, symptoms, and management of the disease diabetes mellitus. And they're giving you all of the stories there. But what I've underlined is what you have to answer. That's the question. Describe homeostasis of glucose, and describe the causes, symptoms, and management of diabetes mellitus. Once you've got that, then you know how your answer is going to be flowed out. I've already given you the start of the challenge question. You deal with it later. Good. The first thing here is in the summary is the definition of egestion. Raven, you want to give us some of your thoughts, egestion? In a nutshell, easy for the children to remember.
Digestion. I'll speak about digestion and I'll come back to you.
You see, he give you a clear, you haven't caught that, but he's giving you a good, you heard what he said? He said, ask me about digestion. After digestion, I'll come and tell you about it. Why? Because when food does not get digested, after the food that does not get digested is the parts that will be egested. Egested. E for exit, E for egestion. So egestion means is that the undigested food is removed from the body. From where? Through the anus, and this undigested food is called feces. So egestion is referring to the removal of undigested food, feces, through the anus. Where is this feces stored before it leaves from the anus? In the rectum. Okay, so that's all you need to know there. Don't go into too much of detail. No, not too much. We don't want to know too much about egestion and how you're doing it and how it smells. No, we don't want to know all that. Good? Thanks for that great answer, Raven. All right. Homeostasis comes from the words homeo, meaning, Raven, any ideas?
Nope.
Homo?
Homo. Nope.
Same? Would be the same. Luni, you better be careful because I'm going to throw some of those questions to you. Don't think only Raven is going to answer the questions. Yeah?
No.
Stasis meaning the state. So if you literally translate homeostasis, same state. That means the same. In this case, not same state as in country, same condition. That's where this word comes from, homeostasis. And what is it actually? It's the ability of the body to maintain a constant internal environment in response to environmental changes. That means no matter what happens outside, certain things in the body must remain more or less the same. We can't say identical because it will never be the case. For example, there's a bit of a heater in the room at the moment. Do you feel that heater, Luni? Or are you still feeling cold? We can't ask Luni because she's a little bit off today.
Yes, I'm
because
sick.
she's not well, so we can't ask her. But I'm feeling hot. How about you?
I can feel it.
You can feel the heat.
Yes.
But if we had to measure Raven's temperature at this moment, we put a thermometer in his mouth or under his armpits, etc., what temperature will we get, Raven?
Plus minus 30 degrees Celsius. 35.
36
36.
degrees Celsius, right? 36 to 37 degrees Celsius.
Mhm.
That is the body temperature, normal human body temperature. So what are we saying? That no matter how hot or how cold it is in this room, our body temperature must remain plus minus 36. And this goes back to your grade 10 work on enzymes. Remember, low temperatures inactivate enzymes temporarily and high temperatures denature them. That means changes its shape and it can't work. And the main way in which we maintain homeostasis in our body is by the release of hormones from the chemical coordination system, which you will learn more about next year. The interesting thing, grade 11s, if you learn this part here very well now this year, this part is included in your next year's syllabus under homeostasis as a chapter, this part that we are dealing with today. So you're going to concentrate, you're going to learn it well, so you don't have to learn it again next year. You will revise it next year, so you know at least one part of your next year's work is done. So obviously, to know the information, the nervous system plays an important role to get stimulus from the environment and make decisions about us. And it can help also not only of the external, but also the internal environment. And the endocrine system then controls the internal environment by secreting hormones. So you can see, just like in everything else, the different systems in the body have to work together. There has to be coordination. Imagine the whole body. You know, that reminds me of a story, Luni and Raven. Let's see if you can share the story with me. The body was in a little bit of a debate. So the I says to the body, I am the boss. Because if I don't see the danger, if I don't see the environment, you can't process any information. If I don't see the beautiful woman and. So the body sits back and the ear says, no, I am the boss. Because if I don't hear the danger from behind, which you can't see eyes, When that guy hoots, you can't see him. But if I didn't hear him, you won't jump out of the way. The cow will knock you, you'll die. Ah. And so the stomach said he's the boss because he doesn't digest the food. And the brain said he's the boss because he doesn't get all this information. And from one tiny corner, the anus whispered, I am the boss. And just like how you're laughing, the rest of the how can you say you're the boss? You're just a hole. What you talking cuck here? Eh? Mind the word cuck and pun, or the pun on the word cuck and anus in the same thing, you know? So the body is laughing. So what does the anus do? Close. Anus blocks. So immediately, and grade 11s, listen carefully, because although it may be funny, listen to the words we're using because it's talking about your digestive system. Anus is blocked, what happens? The rectum starts rumbling because there's things there that need to out, and it can't go out, so the rectum is in turmoil. And after the rectum comes the descending colon, and the transverse colon, and the ascending colon, then the jejunum, and then the ileum, and then the duodenum, and then to the stomach. The stomach is rumbling, and the rumbling is causing chest burn in the esophagus. Now what's happening? The temperature is going up because there's a problem in the body. Eventually the brain is now boiling.
Ooh.
So what do you think the body is going to do?
It needs to find a balance.
So what's going to tell the anus?
It's going to say, open up, Baba.
So, but what does the anus need to hear?
You are the boss.
Exactly.
Oh.
Anus, you're the boss. Ah, it opens up. Ah, relief. What's the moral of the story? Any asshole can be the boss. So don't think you're a boss, don't think you're a boss. Eh? Right, okay, that's so much. But in our bigger picture, what's the moral? That every single part of your body is equally important. And in life, every person in an organization or in your family, every person is important. So appreciate every single, no matter how small you think that individual may be represent in your life. Think about that one. Okay, so we're saying that that's going to happen there, and some examples of homeostasis, and you're going to learn about this next year, are temperature. I'm not underlining blood glucose because you're learning this year, pH, and body fluids, and we can add to that water. We can add, we've got temperature already, we can add water, we can add oxygen, carbon dioxide, all which you're going to learn about more in detail next year. This oxygen and carbon dioxide you've already done. And in grade 11 you're also going to do water osmoregulation, and you've done pH, by the way, because you've learned the kidney. Or you're going to learn about the kidney, and you're going to learn these things in that time as well. Now, this homeostasis that we're talking about, how does it work? In any coordination system, there must be three important things: a stimulus, a control center, and a response. Let's take your house. You want an alarm. You are armed response. So what must happen? There must be a stimulus. For example, you press the panic. That's the stimulus. There must be a control center, the office where this information is going. And there must be a response. They must either phone you to say, hello, is everything fine? Or they must come there to your house to help you if there were criminals in your house. Now, in the same way, any coordination system must have that. And for balance to be brought out, we have the same thing. And let's look at this particular case, and this is dealing with the one that we're learning about. If this is your normal glucose level, this area here, if for some reason the glucose level increases, what is the stimulus? The increase in amount of glucose in your blood. Where does it get picked up? In the pancreas. The pancreas receptors pick this up. What do? They send messages in the form of insulin to the liver, telling the liver that in the liver the following must happen. Glucose must be converted to glycogen, and also the rate at which the cells absorb and use glucose must increase. So you think about it, what has happened? We've taken lots of glucose, but we've converted it to glycogen, something else. And at the same time, we told the cells, hello, take glucose from the blood, take, and use up more. So what has happened to the level of glucose, Raven?
It starts to decrease.
It starts to decrease. And what will that do? It will bring it back to
Normal.
Homeostasis. This is also called negative feedback. Why is it negative feedback? Because the stimulus results in a response in the opposite direction. What was the stimulus? Too much glucose. What was the response? The levels of glucose decrease. Negative feedback. I'm hoping you're catching that one. And let's look at it the other way. The same thing's going to happen. If glucose, for some reason, decreases, for example, when you're sleeping, you're not taking in glucose, so while you're sleeping, your body is using glucose, the glucose level may go down. Or somebody that's fasting, come to which we would be fasting soon, Looney. In 1 month's time, I'm going to start fasting. Then I'm going to be like, we're going to do glucose. There's no water breaks in between. But by this time, it will be nice because what's it now? 5:15? I'll be happy because just now it's time to break fast again. Nice. Break fast.
Islam, no.
Yeah, but not breakfast,
It's
supper.
fine.
Okay, so pancreas receptors, again, can you see that? AlarmNet. I'm saying AlarmNet because I say this at home because that's our alarm company. I'm advertising for the wrong guys now. What? An alarm company. Whether you opening your business or you closing your business, the message doesn't go to two different places, it goes to the same. The control center doesn't change. So even when glucose decreases, the pancreas is what is the control center. And what does it do? It responds. How does it respond? It secretes glucagon, another hormone. Insulin, glucagon. What does this glucagon do? It causes a change from glycogen to glucose. Notice it's the reverse of what we were doing earlier. So now what has happened, Raven, to the amount of glucose?
Glucose must go up.
It goes up to normal. Remember, in both answers, our last sentence was the glucose level comes back to normal. In any homeostasis, your last sentence, you can change whatever you put in your carbon dioxide, water, pH, temperature. You can put all those things there. Your last sentence will be always back to normal. So this is a negative feedback mechanism, and this is the homeostasis of glucose in the digestive system. And like I said, this is prescribed for next year as well. Homeostasis, the meaning, what is a negative feedback, the meaning, and how does it apply to glucose. These are all part of next year's syllabus as well, if and when you get to grade 12. I'm harsh, na? If and when. Good nutrition. I'm not going to waste your time to talk about this. You know that we have fats, we have proteins, and what else again? I caught you there.
And sugars.
Sugars, and sugars are? Kai, Looney, sharp. Looney gets the calculator. I'm giving Looney the calculator today. She got the right answer. Carbohydrates, and we have vitamins and mineral salts. We must have a balance of all of these things. You all are Google-friendly people. You can Google and you'll find a diagram like this that will tell you of what you need so much. But the bottom line is you must eat all of these things in moderation. Not too much of any one of that. It can cause harm to your body. Good nutrition, we're not going to go there. Malnutrition. Nutrition gone wrong. Nothing's right about it. So malnutrition means that you are either eating too much or too little. It can go either way. And we're talking about overnutrition, undernutrition, etc. We got examples like kwashiorkor, nutritional marasmus, anorexia nervosa, bulimia. All these are examples of malnutrition. With that short summary, Looney.
Alright, mindset is let's take a very quick break, but we'll see you straight after this. Back what are you? I'm sorry guys. Welcome back. My set is from the break. Almost as why are you laughing? But you can't even see the person who's laughing. Anyway, quick shout out to Nioza Simbine, who says he wants to make his mommy proud if I say his name on TV. So hi. And then quick shout outs to all of Bongi Lamini's friends from Abel Motuane. They're writing a life sciences test tomorrow, so we wish you everything of the best. And mindsetters, I can see a whole lot of you are stressing out now about the view link. I've just posted it on our Facebook page, so if you want to view the notes, I've posted the link on our page. So don't stress, we've got you.
Thank you, Luni. You're helping him, stressing him out, the poor things. As it is, they stress, they're seeing this old grey-haired man with big hair on his face, not on his head, compared to the bald one and the blonde one they've been seeing all this time. Now you stress
They're complaining.
They're
like,
complaining,
what's
what the hell, what happened to
what
Llewellyn?
happened?
Yeah, you must keep Llewellyn in your prayers, guys. Yeah. In the meanwhile, I'm hoping I am doing justice for him, for you. Good friend of mine, Llewellyn. Right, good. First question. Oh no, let's first go back to that last part of the summary. This circulation you learnt in grade 10 as well, the hepatic portal circulation system. The purpose of the hepatic portal system is to supply and remove, mainly remove or drain the organs of the abdomen. The blood from the abdomen must get back to the heart, and from the heart. Remember, digestion is taking place in the abdomen. And the digested food must go to the heart, and from the heart it must go to all parts of the body. So this system here is telling you about what's happening. Obviously, the capillaries from all, the villi, for example, they fall venules. The venules join with venules from the stomach to become known as the hepatic portal vein. So all the venules combine to form the hepatic portal vein. And it forms the hepatic portal system. The hepatic portal vein then transports amino acids and glucose especially to the liver. In the liver, certain things happen. These things get processed. Amino acids, if there's excess, it becomes deaminated and goes to the kidney, and anything that is extra in glucose, we heard earlier what happens, it is converted to glycogen and stored in the liver. From there, out of the liver, it goes into a series of capillaries, and then again it joins outside the liver. So in other words, normally what happens, artery becomes capillaries, capillaries become venules, venules become veins, and it goes to the heart. Here now we're saying that the capillaries became the vein, but the vein becomes capillaries again when it comes to the liver. Outside the liver, they combine again to form the hepatic vein. Here we have it here. It doesn't say it here, but it becomes a hepatic vein. So we're having the hepatic portal vein. We had capillaries that became venules, that became hepatic portal vein, that became capillaries again, and obviously that will become venules again, and it will form the hepatic vein. These are two different ones. The one that goes from the abdomen to the liver is the hepatic portal vein, because it's draining, portal draining, and the hepatic vein is the one that goes from the liver to the heart. Not even to the heart, but to the inferior vena cava, if you want to be more specific. There we have that there. That was the last part of the summary, as we may call it. So we've got enough time with you for questions. The first question is an easy one. Define the term homeostasis. Level 1 question, define the term homeostasis. And we've done that already. And homeostasis is when the internal environment of the humans remain, not only human but any organism. Homeostasis means that the internal environment remains constant or stable. And we must add the other part. But here it was 1 mark, so it's only 1. But normally they ask for 2 marks, irrespective of any change outside. Irrespective of any change. Hot or cold, lots of water, less water, our body must stay the same. The next question now is testing that homeostasis. The flow chart below illustrates a process of feedback control involving the endocrine system. An example of this feedback system occurs in the human body when the blood sugar content of the blood becomes low and needs to be controlled, or becomes high and needs to be controlled. So they're giving you a schematic diagram. They're not telling you which one it is, who is doing what. It says the endocrine organ. There's a target area there. There is a feedback or a stimulus that comes to the endocrine gland. It sends a message to a target area. There, the target area brings about a response, and so this cycle continues all the time. For each of the following, describe how blood sugar control is affected by the endocrine organ. This is the endocrine organ. And when it comes to blood sugar, which one of Looney and Raven can remember which organ was involved in regulating the sugar level?
The pancreas.
The pancreas. Looney, hey, calculate, I take back.
I was thinking
I'm giving
pancreas
to Raven.
actually.
Now you see, I don't want you to think. I want you to tell.
It was like right
It was
here.
there. Good. So it's the pancreas. They want to know from you, how does the pancreas control sugar level? Obviously, we can talk about high or low, but in this case here, he was talking about low in the question, so the examiner was talking about low, so we'll continue with that. First of all, receptor cells in the pancreas can sense the increase in glucose, for example. If there's an increase in glucose, the receptor cells in the pancreas, they pick this up. So they have picked up the stimulus, because that's what the receptor does. It picks up a stimulus and converts it to an impulse. What does it do then? The pancreas is the control center, so it must respond. It must bring about a response. What does it do? It secretes the hormone insulin. Remember, the problem was high glucose. So it secretes insulin, and this will cause the blood level of the glucose to decrease. But also, so that will be the one part. So it's going to cause glucose to decrease. But sometimes in between meals, we have a natural decrease because we're not eating. We've digested the food and the food is gone. So now the levels of glucose decreases. Now what can happen, because they didn't say whether low or high, here they're saying anything. Receptor cells in the pancreas sense the decrease. In this case, it will secrete glucagon, and glucagon will decrease. Aslam. No calculator for you. Increase the glucose level. By the way, you know when we say that, how? By converting glycogen to glucose. Notice the hormone is called glucagon. The compound it works on is glycogen. Now, just for this once, instead of saying the word properly hormone, say hormone. What, Looney?
Hormone.
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 Hormone, glucagon.
Ah.
So you're going to remember that the hormone is glucagon.
Okay.
And the carbohydrate is glycogen. Many times, if I give an exam now, I can write the remedial work. Learners have confused glycogen and glucagon. So hormone, glucagon. Remember that. You're going to remember that for a while. Which is the messenger? What is the messenger in this particular case here? This messenger here. Which messenger? It depends whether you're talking about an increase or a decrease. Right? It could be either insulin, when there was an increase of sugar, or glucagon, when there was a decrease. Okay? The target organ, obviously from the previous sentence you can get it, it will be the liver. In both cases, it will be the liver cells. The target. Remember in this question, it only asks for the target organ. The target organ, you can't even say liver cells actually, is the liver. The target organ, liver. That's all. It didn't say explain, they just had to give you that there. If they say what happens there, then you're going to explain these things as well. Remember that. Okay, we're still continuing with that. Describe, now listen to the question. Describe the target organ's response and explain, lots of verbs, effect or feedback on the endocrine organ when the human body responds to a shortage of glucose. Interesting stuff. Okay, now I'm going to go a little bit down for that one because I'm going to, right, let's go here. So they say there's a shortage. What did they say? Shortage of glucose. No? So glucose levels are low. How does this organ deal with this? When the levels are low, the receptors in the pancreas sense this, and the pancreas secretes glucagon, which will convert, what's that other word, Raven?
Glycogen.
Glycogen, good. Glycogen into glucose. What does this do to glucose?
It increases.
Increases. glucose level to normal. By the way, they asked about the target organ. So we're somewhere in between. We must fit in the word what?
Liver.
Liver. So where? We can fit it here. Pancreas secretes glucagon, which converts glycogen to glucose in the liver. In the liver. This increases the glucose level back to normal. The next question is very similar. It says, discuss the role of the pancreas in maintaining the glucose balance in the body. Now, this first part is 1. That's 1, if it's low. And obviously, then we must also talk about when it is high. Then again, the pancreas, which receptors sense, and therefore the pancreas secretes. Now, Raven?
Insulin.
Insulin, good. Which will convert glucose to glycogen, the reverse of glucagon. And also increases the absorption
Right.
and usage of glucose by the cells. And this causes glucose to increase or decrease? Ah, decrease
Decrease.
to normal. Mindsetters, I'm hoping you got that. So this one here was talking about the whole story of the pancreas, and again there would be more marks for that, but you could just talk about just secreting up to where it secretes also, that's fine, or you can take it right through. But notice that this answer that we've given here at the same time talks about the homeostasis of glucose in the body. The next question, the table below shows the arrival and departure times of a particular meal for certain regions of the alimentary canal of 6 patients, A to F. Study the table and answer the questions that follow. So they've given you 6 patients, arrival in the stomach, departure from the stomach, almost like an airport is sounding here, and departure from the small intestine. Notice they haven't given you arrival in the small intestine because it's obvious. Why? When it departs from the stomach, where does it go? It goes to the small intestine. Good? I'm hoping you understood that. That was the first thing that you had to know. So they're giving you times there. They say which patient was the last to have a meal. Now, did you have to study your work to answer this question, this first question? Not at all. What you have to do? You have to look at the table and read information from this table. Which one got food last would be obviously patient E. Why we say it's patient E? Because he got it at 6:50 and the others at 6, 6:10, 6:20, 6:30, 6:40. So his food came into the stomach last. So we assume that he ate last. Because generally, from the mouth to the esophagus, it's the same distance between most people. Unless someone is very tall and his neck is so long, it's not going to happen so much. Generally, it will be there. The next one says, how long did the meal remain in the small intestine of patient E? Now they're giving you instruction. You must look at patient E and you must look at the small intestine, the departure, but they're asking you, how long did it remain there? Now you notice the clue I gave you earlier. It departed from there at 11:50. What time did it arrive? It arrived around this time. The time it leaves the stomach, because from the stomach, short distance you're getting the duodenum. But we need to calculate it. And how do we calculate it? Very easy. We take the time of exit minus the time of arrival. So therefore your answer is 2 minutes and 53 seconds. Not 2 minutes. Ha ha ha. What was my mistake, Raven? 2
hours.
2 hours, because we're talking of 11:50 and 8:57. Can't be 2 minutes. It would have been 8:57 and 8:59 if it was 2 minutes. Huh? That's hours that we are talking about is different. 2 minutes and 53 seconds. The next one was stomach of patient D. Obviously the skill that you're going to use is the same. We go to patient D. We look at arrival in the stomach is 6:30. and departure is 8:27, so our answer must obviously hinge around that. It is time in stomach, time of exit, time of entrance. 8:27 minus 6:30 is 2 hours, 2 hours and 22 minutes. I'm hoping you're seeing, people, a data response question is where you have to read the information, understand the information in a table, in a graph, in a passage, in a case study, and then answer it. Or in diagrams, maybe they give you flow diagrams and they're asking you questions about that flow diagram. So there will be a mixture between your knowledge and the data that's found there. You need to marry the two to answer many of the questions. We still with the same question. Food generally remains longer in the small intestine than in the stomach. Now notice, now you needed to use your knowledge of nutrition. You can't get that from here. It's not given in a table. It says, why is it different? Why does it last longer in the small intestine? For a start, think of those two organs and their size. The small intestine, don't be fooled by the word small, and the stomach. Raven, any ideas there?
I think your small intestines have a larger surface area.
They have a larger surface area. Excellent. And to cater for this, how are they put into the body?
They are stuffed.
And?
Curled, coiled.
Curled, coiled,
yes.
Folded. Excellent, excellent. Remember, in biology or life science, whenever a structure has folds or coils or whatever, you remember it is there to, what Raven said, increase the surface area. So it has a larger surface area. Further to that, final digestion is taking place in the small intestine. And there's lots of digestion taking place. So therefore, the longer it stays in the small intestine, and further to that, a lot of absorption also takes place in the small intestine. Good? So digestion ends and absorption occurs in the small intestine. Mainly the absorption, so the longer it stays in the small intestine, the more you can absorb. There is some absorption that takes place in the stomach, remember that. There is some absorption that takes place in the stomach as well. In fact, if you have glucose in your mouth, absorption will also take place through the cells of your mouth as well. Describe the absorption of glucose as it takes place in the small intestine. How is glucose absorbed? First of all, we must know that glucose is the smallest structural, functional carbohydrate. The molecule is glucose. It's a building block, monomer, building block of carbohydrates. And in that form, it is soluble in water. As it is soluble in water, it will dissolve in water and diffuse, either diffuse from the alimentary canal into the capillaries of the village, or it can be transported by active transport. What does that mean again? It means that we need energy to transport the food. All right, so some by diffusion, but mainly by active transport from the intestinal lumen, in other words, the space in the alimentary canal, into the blood vessels or capillaries of the villus. From there, it will be transported, eventually hepatic portal vein, liver, hepatic vein, heart, and it will move from there. With that, Looney.
Okay. Mindsetters, let's take a very quick break, but we'll see you straight after this. Welcome back, Mindsetters, from that break. A big congratulations goes out to Vincent Souza. You have won yourself this awesome Casio calculator. Congratulations to you. Mindsetters, if you want to be like Vincent. Yes, yay. Wondering what you're doing. If you want to be like Vincent and win yourself an awesome Casio calculator, all you need to do is enter the Taste Itself competition. I will post all the information on our Facebook page so that you can stand yourself a chance to win. Answer all the questions, get them right, you might win a calculator.
Even faster.
That's getting faster.
I'm giving
Guys,
you time.
we jump into the
You
challenge
need
question
time.
and then we'll go to question 3. Because the challenge question is dealing with an important concept. So let's look at that again. Remember, we underlined the keywords and we've read the challenge question already. Now we're just going to show you what you should have included in your answer. and also to show you how you set out your answer in an essay. Okay, so the first part of the question said, when abnormal levels of glucose are detected, what happens? You are telling them it's detected by the pancreas. That's your first mark. You can say the pancreas secretes hormones. You don't have to say islets of Langerhans, but it's better because more correct, it's the islets of Langerhans of the pancreas. And if you want to get more correct, you'll talk of the alpha cells and the beta cells. But for your syllabus, pancreas is good enough. Where into the bloodstream. So it's already just 3 marks from saying that one sentence. When the blood glucose level rises, we've already done this before, that's why I'm going through faster. I'm showing you how the marks are given, and at the same time, I'm trying to show you how you need to set your answer out. So first, you're talking about the first part, because that was the first part. Describe the homeostatic control of glucose. They didn't say high or low. So you're starting by saying, generally, this is what happens. Secondly, if it is high, this is what's going to happen. Insulin is secreted to decrease the blood glucose level back to normal. We can also say that blood, how it's brought back to normal by causing glucose to be converted to glycogen, and we can talk about the increase of the usage of glucose. Right? Back to normal. Then, if it falls or decreases, or too low, then pancreas secretes. We've already given you a mark for pancreas. We're not going to give you another mark for pancreas. So glucagon is secreted to increase the blood glucose level, and you can explain how. By converting glycogen into glucose. And back to normal again. Right? You notice any 10 of the above points. And look at, let's count. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. There's only 10 there, okay? But we could give you more even there in islets of Langerhans and the rest of it, okay? So they're giving you 10 points there. Then the second part of the question spoke about the causes, symptoms, and management of. Notice what we did first, we answered first. What we did second, we answered second. So causes of diabetes mellitus, first of all, inadequate or non-secretion of insulin. That means not enough insulin is secreted, or there's no insulin. Or sometimes the insulin that is secreted may be faulty also. Or sometimes we can even talk about that the cells, they're getting insulin, but they're not following the instruction of what insulin is asking them to do. So that's also another form. So production of defective insulin, or there's it there, I've given you all 3 there, all 4 there. Any one of those can cause that story. Or the inability of cells to use glucose efficiently. So those are the causes of diabetes mellitus. Symptoms, one of the first symptoms we'll find glucose in the urine, but that's if you test it. Obviously you're not going to see glucose in your urine if you're urinating. The other symptoms that you'll find are 1, frequent urination, extreme thirst very often, especially when you're sleeping, fatigue, lethargy or faintness, you're feeling weak generally because you are not getting enough storage sorted out there, nausea, vomiting, weight loss sometimes, blurred vision, and this one here is something you must take care of very urgently if you have this. If you're finding that you're getting cut or bruised, and these bruises or cuts are not healing very fast or fast enough, you need to be doing a sugar test, because if you allow that wound to last, you may get gangrene, and they may have to amputate the organ. So before it gets that, you see that, this wound is taking long, rather go and see the doctor. Worst case, he tells you there's nothing wrong with you. Well, that's not the worst case, that's a good case. But he may think, hey, why are you worrying for nothing? I'd rather have that when I go to the doctor, he's telling me, no, you mustn't worry. Then, not worrying about it, and when I go to the doctor, he tells me, why didn't you come earlier? Huh? Because then I've got to chop your leg off now. Oops, it's too late then, huh? Right? And the management of diabetes mellitus, exercise, eating diet suitable, using prescribed medication, etc. Those are the story. But for me, these 2 for diabetes are more important than taking the medication. The more you exercise and the more you eat a diet that is suitable for diabetics. That means you do not punch yourself too much with sugar. You take a low GI type of meal. You will see the difference immediately. And exercise does not mean, hey, I must go to the gym. 1, 2. No, that's not what I mean. Walking around your house, that's exercise. Walking in your house, that's also exercise. The minute you finish eating your meal, pace around the house and see how you can get that done. Huh? So you can look at what we're saying. Content is 17. And we give you, I just want to see if they've done it on the next page. No, they haven't done it. For synthesis, we give you 3 marks. Now, synthesis means, again, I look at what? I look at relevance, logic, and comprehensiveness. If you didn't talk about something else here, you didn't talk about egestion, you didn't talk about absorption, that wasn't necessary. If you spoke about it, you're not getting you'll get either 0 or 1, 0 or 1, 0 or 1. So if you spoke about only these things, even if your answer is not finished, but you only spoke about, maybe you didn't talk about the symptoms, but you didn't talk about anything extra, you'll get the 1 mark. And if your answer was followed, even if your answer is not complete, but it followed a logical sequence, you will get this 1 mark. But if it's incomplete in some ways, you're going to lose this mark here. But more importantly, notice that the 17 is much more than the 3. So in life science, you must concentrate on the 17 facts that you have to give. We are looking for 17 facts. You need to give us those 17 facts. Let's go back to question number 2. I'm going to look at number 3, sorry. They say, look at the graph below and answer the questions that follow. What happens to the blood sugar level every time this person eats a meal? So they're telling you, here's breakfast, here's lunch, and here's dinner. What's happening every time they eat a meal, Raymond?
The glucose goes
Did you have to study for that, Raymond?
No.
Where are you seeing it?
It's right
In the
there.
graph. The data is there, given to you. You just need to read the information from the data.
3 marks.
3 marks, exactly. But you must have the skill of reading a graph for that 3 marks. Huh? Okay? How many meals does this person have per day? 3 marks. This is more than 3 marks. How many? Rooney, how many meals?
3.
3. You sure, Rooney?
Breakfast, lunch, and supper.
You sure? 3 meals, obvious. According to the information on the graph, what happens to the excess sugar you eat? Listen very carefully. According to the information on the graph. According to the information on the graph. What happens to the excess sugar that you eat? Hey, Vena. What's happening, Raven?
It is decreasing.
What happens to it, but?
Energy.
Converted to fat cells.
Fat cells. Yes.
So that's the other thing. Instead of talking about glycogen only, remember, glycogen is what you know because you studied it, but also in terms of that. I'm going to stop at that level. I'm going to ask, let's take 1 or 2 questions quickly, Luni. 1.
Okay. Tabo Semenya is asking, can you please re-explain the answer in question 1.1?
1.1. Let's see if we can get there fast enough, Tabo. It'll take us longer to get there, I think. 1.1. Tabo, you're lucky you're not sitting in front of me, Tabo. Define the term homeostasis. What's it to explain? Homeostasis is the maintenance of a constant internal environment, irrespective of any change that's taking place. For example, if the glucose level in your body must be 100 milligrams per liter, then if it goes up or down, we need to bring it back to normal. That's what we mean by. Yes?
Okay, and then Lupello is asking, I'd like to know the efficiency of absorption.
Oh, yeah, that's a good question. It's going to take long. Lupello, no? The efficiency of the absorptive surface for absorption. The absorptive surface in our body is the villus. First of all, the villus has a large surface area. Why? Because there are millions of them and they are folded. Secondly, it is made up of a single layer of columnar epithelial cells, so they are thin, so easy diffusion or absorption. Thirdly, it is richly supplied with blood vessels, so it can transport it. Fourthly, it's protected because it's inside the body, and it has mucus which keeps it moist. So these are the 5 things that you must look for the gaseous exchange surface and a digestive system to make it, absorptive, sorry, to make it efficient. I think that will answer your questions, Lupelo. And with that, guys, thank you very much for allowing me entry.
One more. Can
You
you
got
take one more?
Yeah?
What is meant by active absorption?
Active absorption. Active absorption means we're taking something from downhill and we're putting it uphill. That means the concentration where we're taking it is higher than where we're taking it from. So to do this, think about a rock at the bottom of a hill. If we want to move that rock up, we've got to push hard to put it up. But if it's at the top, we just push it and it's going to roll on its own. So active absorption means absorption using energy.
Cool. Thank you for that, Aslam. Thank you,
Thank
guys.
you, Raven, for joining us.
Yes, I was going to say
Ah,
that.
sorry, man. I
You
always
like to jump the
say-
gun.
Aish,
you.
Aish,
Ah,
Aslam.
ah, ah, ah,
Aslam.
ah. Oh, Aslam.
Can I
Thank you,
send a shout out?
mindsetters, for tuning in. Thank you, Aslam. Thank you, Raven, for joining us. Can you send us shout outs?
Yes.
Yes.
Big shout out goes to the company that made it all possible for me to be here, the British Council of South Africa. Another shout out goes to Tebogo Mokhorozi and Tumelo Tebe in Mafikeng, who promised to be recording this show, especially for me. Big shout out to my fellow students at the Northwest University, and as always, Bonato Park High School, thank you so much. It's all because of you that I'm here today.
Oh, you molded a little brain into a masterpiece, and now he's thanking you. Thank you so much for that, Raven. Thank you for joining us in studio. Mindsetters, thank you so much for tuning in. Until next week, we'll see you then. But from then, till then, it's goodbye from us.
Thank you.